Artificial intelligence is changing everything, from the way we live, work, and even how we understand the universe. This year, AI took center stage at the Nobel Prizes in chemistry and physics. But what does this transformation mean for science? And should we be worried? AI is revolutionizing scientific discovery. Just look at AlphaFold, an AI model that can predict protein structures with unprecedented accuracy. Its impact was so profound, it helped earn the 2024 Nobel Prize in Chemistry. But as some of the laureates have noted, this is just the beginning. AI is poised to accelerate science at breakneck speed, pushing the boundaries of what we thought was possible.
The potential is enormous. We're seeing AI tackle problems that were once considered unsolvable. It's an exciting time to be in science.
Yet, alongside this excitement, there are concerns, serious ones. Scientists using AI can fall into three major illusions. The illusion of explanatory depth, where AI predicts outcomes but doesn't fully explain them. For instance, AlphaFold can predict protein structures but can't explain why they form in certain ways.
The illusion of explanatory depth is a real issue. We need to understand the underlying mechanisms, not just the outcomes.
Then there's the illusion of exploratory breadth. AI might be testing only a limited set of hypotheses, giving scientists the false sense that they're exploring all possibilities.
Exactly. If we rely too heavily on AI, we might miss out on important discoveries because the AI isn't looking in the right places.
And finally, the illusion of objectivity. AI models may seem free from bias, but in reality, they reflect the biases present in the data they're trained on.
This is perhaps the most dangerous illusion. Bias in AI can perpetuate existing inequalities and lead to flawed scientific conclusions.
AI is also making science cheaper and faster. Take Sakana AI Labs. They've developed an AI scientist that can produce research papers for just $15. But while this may sound groundbreaking, critics are calling it a recipe for endless scientific slop.
Do we really want a future where AI churns out endless research papers with little value? This could bury meaningful discoveries in a sea of noise.
The push for cheaper, faster science needs to be balanced with quality and integrity. Otherwise, we risk flooding the scientific community with information that lacks substance and value. And let's not forget public trust. During the COVID pandemic, we saw how calls to trust the science were met with skepticism. The rise of AI in science could deepen these issues. If AI becomes the dominant force in research, will people trust the results? Or will the complexity of AI make science even harder to understand for the public?
Transparency is key. If we want the public to trust AI-driven research, we need to be open about how AI systems work and how decisions are made.
As AI shapes the future of science, it's time to rethink the relationship between scientists and society. Some argue that we need a new social contract, one that ensures AI-driven discoveries benefit everyone, not just a select few.
What about the environmental cost of AI? How do we align AI research with society's expectations and ensure it serves the public good?
We stand at a crossroads. Will AI be a tool that strengthens science's ability to tackle humanity's biggest challenges, like climate change and social inequality? Or will it lead to a scientific monoculture, dominated by algorithms and data, disconnected from the nuances of real-world problems?
The need for diverse perspectives in AI development cannot be overstated. We must include voices from all walks of life to ensure AI serves everyone.
Science should serve society, and AI can play a crucial role in this mission. But we must guide its development thoughtfully, ensuring it reflects the values and needs of diverse voices. The future of science with AI is exciting, but we must ask the right questions now to ensure it's a future we can trust.